This is Math 30-2 for Wednesday, December 2nd, 2015. I am going to do the video just in case we end up not having the Moodle available to us, having Moodle available to us. So in this course, this lesson, we're looking at modeling data with sinusoidal functions. We're going to graph data. We're going to determine the sinusoidal function that approximates the data or represents it. We're going to learn how to interpret the graph of these functions that models a situation and explain how the reasoning that we use. And we're going to use technology in contextual problems. So we'll find data that best represents our graphs. Okay, so let's start. Here we're going to practice doing a sinusoidal regression. So we've got the following data. The first thing we do is always enter the data into our scatter plot or into the stats. So we turn the calculator on. I'm just going to clear this, go in stat, and then edit. And we put our data, our x in list 1. So we have 0, 1, 5, 11. Oh, I don't know where I got 11 from. Oh, 5, 7 is the next one. So let's clear that. Seven and 10. Now we will look at entering list 2, data into list 2. That's 9, and here's where the 11 came from. So we have 11, 25.7, and we have 23.2 and 8.7. So now we want to set up our windows so we can see the data. We're going to go from 0 to 10 on the x. So we'll start at 0, go to 10, and we can go up in steps of 0.5. And in our y, I'm not sure how low we're going to go. The lowest data value we have is 8.7, but let's start at 0 just to make sure. We can readjust that. And again, we know our highest value is 26 approximately. Let's go up to 30, and if we need to, we can go further. And we'll do steps of increments of 2. And the next thing we need to do is turn our stat plot on. So we go into Y1, turn the plot on, we press enter, and now we should be able to graph and see our data. So we can see our first data goes up and it comes down. So we'll do our sinusoidal regression, and then with that regression we'll be able to plot the equation. So to do the regression, we go stat, over to calculate, and you'll see of course that it's not here. I'm going to scroll up, and you can see that the sign regression is C. So enter on, well, put the calculator on C and press enter. It's going to do 3 iterations of the regression, and so it processes it through the algorithm 3 times. That's an adequate number. I wouldn't change that. Our X data is in list 1, our Y data is in list 2. If we know the period exactly, we can enter it, but we don't have to. So now comes our storing the data. We want to access Y1 to tell it to store there. To do that, we go into our vars, over to Y vars, and number 1 function, enter, and we'll put it into Y1. Now we will calculate, and it takes a few minutes and it goes through the calculations. So we've determined our equation. We have A, B, C, and D. So now they're a little bit different from the B and the C are a little bit different from what we talked about in our last class, but let's just record this. This is y is equal to A, which is 8.9 0, we're going to use the nearest hundredth at this point, times the sine of, and notice here on the calculator b is inside the brackets. So our b value is inside. We have 0.567 times x plus negative 1.4, and let's use 3 decimal places here, 1.436, close the bracket, plus 17.45. And that, we'll leave it like that. Now, our period is still associated with B. What becomes more complicated is if we're looking for our phase shift or our horizontal shift. But at this point, we don't need to worry about that. Now let's graph this and see how the equation fits the data. So we can see so far that it's doing a fairly good job of approximating the data. It's running right through it, and so we're doing okay. Now, let's use our data to determine our amplitude, our period, and our range. So our amplitude comes from A, and so the amplitude is 8.90. This data, we don't have any context for it, so it's just the numerical value for our amplitude. Remember that we can calculate our period using that relationship of 2 pi over b. So the period gets calculated using 2 pi over b, and or we could also use degrees, but by looking at this value here, that isn't a degree measurement, that's a radian measurement. If we had 60 or 90 or something quite a bit larger, then we would think about being in radians or degrees. Now, the other thing is if I go to my window, or sorry, into my mode, we can see that my calculator was set in radians. And so the work that it did, that regression it did it in radians. If the calculator had been set in degrees, we would have gotten a different value there because it would have been set for an offset in degrees. It's generally, we do our regressions in radians. Sometimes that changes, but so we're set in radians. So now let's go back and calculate our period. So our period is 2 pi divided by 0.567. So 2 times pi divided by 0.567, and we get 11.08. So our period is 11.08. Now remember, if we think in terms of radians, 2 pi is the distance around once. So if I take 2 and pi and calculate it, we can see that that's 6.28. So our period is almost twice, not quite twice 2 pi. And remember that this tells us, B tells us the number of cycles in 2 pi. So we have more than half a cycle, but less than one full cycle. And so that's why our period is the 11.08. And if we're interested in determining what it would be in terms of degrees, we can do that calculation. Remember that we can convert our radians to degrees by going, what degree would we have for 11.06 radians, given that we know 180 degrees is equal to pi radians. So we calculate x by taking 11.08 times 180 degrees over pi, and we're left with our measurement in degrees. So we can calculate that just out of curiosity and see. So we have times 180 divided by pi. And so this is 635 degrees approximately. Now, the range. We can determine the range. We want to know what our lowest value is, and so to get our minimum, we take our D and we subtract A. So we take D, which is our midline, and subtract A. How far below our midline do we go? And so I have 17.45 minus 8.90. We can calculate that. And we go as low as 8.55. To get our maximum, we take our midline, D, and we add the measurement, or add the amplitude. So here we have 17.45 plus 8.0. Again, just to check this on the calculator. Add it, and we go as high as 26.35. So our range is 8.55 is less than or equal to y, which is less than or equal to 26.35. And if we use a proper notation, that's y such that y is equal to, and I was just squishing it in there. I'll write it over here now. Range is y such that y is 8.55 less than or equal to y, which is less than or equal to 26.35, and y comes from the set of real numbers. So that is our example on using the sinusoidal regression. And I said to 3 decimal places here. I didn't do that with my A and my D, but certainly with the B and the C we would do that. Let's now go to finding the equation given our graph. So we can see, just if I draw this fairly carefully, we can see that we've got a sinusoidal pattern happening here. And we can find the equation. We'll do that by looking at, we can enter the data, but let's do this just by looking at our values to start with. So we know that we're at our lowest point right here, and we hit that lowest point again right there. That is one complete cycle, and so our period is 16. We don't know what 16 what, seconds, minutes, meters, we're not sure, but we know it's 16 because we have one complete cycle. We know our range because we have our maximum y value, which is 18, and our minimum y value is 2. So we know that our range can be given as y such that sorry, let's erase this. Y is, 2 is less than or equal to y, which is less than or equal to 16, and y is from the set of real numbers. We can take and find our amplitude because we have our maximum and our minimum, and to find the amplitude we take the maximum plus the minimum and we divide it by 2. No, sorry, that's the midline. To find the amplitude we take the maximum and subtract the minimum. So the distance from the bottom to the top is 16, and why I divided it by 10, it should be divided by 2, so 16 divided by 2 gives us an amplitude of 8. And so I know my period is 16, I know my amplitude is 8, and if I look here, this is, if we think about this, our midline is 10, right? If we take 18 plus 2 and then divide it by 2 gives us 18 plus 2 divided by 2 is 10. And so that gives us 10. So really, I can do everything but my C value in terms of my equation. My amplitude is 8. My midline is 10. I can find B by taking 2 pi divided by the period. That gives me my B value. So I have 2 pi divided by 16, and keeping this in exact values, 2 over 16 is 1 over 8, so I have pi over 8 is my B value. So B is equal to pi over 8. And the only thing that I have to struggle with is C. Now, let's think about what our graph would look like with a sine. It would go up like this, it would hit its maximum, come down, hit its minimum down here. So the minimum that's closest to the place where the unshifted graph would be back here. So we are going to the negative, and that occurs at pi. Remember, this whole thing is to 2 pi. Sorry, that's pi over 2, my mistake. So the whole distance across is pi, or 2 pi. Where it meets again, that's halfway. Well, halfway around is pi, and so this maximum here occurs at pi over 2, and that horizontal distance is the same here, so it's negative 2 pi. So our C value is negative 2 pi. That's because this point, this starting point, if it should have been sitting here, so we've shifted everything back 2 pi, or pi over 2. Okay, so we can write our equation. Y is equal to 8 times the sine of pi over 8 times x plus pi over 2. Remember, that's plus, subtract negative, that gives us a plus, and then we have plus 10. Now, I'm going to enter this data, and I'm going to see how closely we've gotten to our equation. So I'm going to turn this on. I'm going to show you a new way to clear the lists. Go to second and memory, and see here number 4 is clear all lists. So if we go 4 and enter, we have empty lists now. So I go to stat and enter. You can see my X, or my list 1 and list 2 no longer has data. So I'm going to enter my X values into list 1. We have 0, 4, 6, and 8. No 10, but 12, and then 16. We go over into list 2, and we're going to do the Y values. We have 2, 10, 15.66, 18, then down to 10 again, and then down to 2. Now we're going to do our sinusoidal regression, stat, over to calculate. I'm going to go up, and then I can see arrow up to C. I do my regression 3 times. I have list 1 and list 2. I'm going to store this, and I didn't clear out list 1, so I'm going to put it into list 2. And that's just because I remembered that I didn't put it in list 1. So I'm just going to put it in list 2 and calculate it now. And notice I have 8. Well, my value here is 8.02. So pretty close. Oh, I have pi over 8. What exactly is pi over 8? So let's write this equation down from the calculator, and I'll put the equation from the calculator in a different color. I'll put it into blue. So we have y is equal to 8.022 times the sine of, and our b value, remember the b is inside here. We have 0.394 or 395 x, and it's negative, so that's subtract 1.25, and I'm multiplying this, or sorry, adding, and I have 10.03. So pretty darn close. Let's just test this out. What is pi over 2? And if I calculate, I take pi, divide it by 2, we can see that, oh, look at that, perfect, almost exactly. Now let's test out and see what pi divided by 8 is. And look at, we have here it's 0.383, and I have 0.385. So again, very close to the values I calculated by doing this by inspection. Now we want to graph this so we can see our equation. First I'm going to go in here and I'm going to delete the equation from my last regression, and then I'll go to my windows. On my x value, I need to go up, probably up to 20. Let's go from 0 to 20, and we'll go up in ones. And then we don't need to go as high as 30 this time. Let's go to 20, and we'll go up. Oops, sorry, that's 0 to 20. There we go. And we'll go up in ones. And let's graph. There's our data, and then there's our equation. And so it asks for the equation. We've got our equation. Either equation is adequate. Since we're graphing it in our windows, we know that we went from 0 to 20. I just want to double check. Yes, 0 to 20 for the x, and with a scale of 1, and for the y, I have 0 to 20, and also a scale of 1. Our amplitude is given where we calculated it. Our period we've calculated at 16. We can take our 0.3895 and calculate, and we'll get a value very close to 16. And we've calculated and determined our range, which will work. I am going to stop and do a second recording with the examples.